I'd like to show you another method by which we analyze a concept that we've already talked about known as moles. Now, remember that we've already spent some time in class talking about the idea of a mole equaling the molar mass in grams. Now, remember that we get that measurement off of the periodic table, right? That it simply is the atomic mass of a substance just using the unit grams. But there's another method or another, relationship that we have in terms of moles, and it's this idea that was understood through the use of a scientist named Amedeo Avogadro. He had been analyzing and had discovered that 1 mole, or the molar mass in grams of any sample of a substance, whether it's an element or whether it's a compound, that it would actually always have the same amount of particles. That number became known as Avogadro's number, which simply says that in 1 mole of any substance that there will always be 6.02 times 10 to the 23rd particles. Now, to picture how big that is, it would be like taking 602 and then putting 21 zeros on the end of it. That's a really big number. That's a lot of particles that are found in 1 mole of a substance. But with that in mind, what that does is it gives us another relationship. It gives us another method by which we see that 1 mole of a substance equals something specifically. Now, particles can be called several different things, but specifically, when we're talking about particles, we could be talking about atoms, if it's an element, or we could be talking about molecules or formula units if we're dealing with a compound. Now, as we get into the next unit, Unit 3, we're going to start to see that where we use these different words, but specifically with molecules, generally it's if we're talking about something that's covalently bonded. We'll find out what that means in the next unit. I don't imagine that most of you know what a covalent bond is, but some of you might remember it from middle school if you learned about it in middle school. And then formula units, we generally use that when we're talking about things that are ionically bonded together. Same idea, right? So some of you might know those words because you learned about it in middle school. If not, we're going to spend a lot of time talking about it in the next unit. But those are some different ways that we might describe particles. We might use the word atom, we might use the word molecule, or we might even use the word formula unit. With that in mind, let's just take a problem. So let's say that we were being asked how many atoms are in 3.4 moles of sodium. Now, this should look very similar to the dimensional analysis problems you've done in the past, because really we just have a known and unknown problem, right? We've got a known 3.4 moles. We've got an unknown how many atoms, which means we could use dimensional analysis to solve this. So let's just start with, since we know our known and our unknown, let's start with the relationship. We already said in our discussion on the previous slide that 1 mole equals 6.02 times 10 to the 23rd particles. Now, the word particles here is being called atoms, right? So we could just simply say atoms of sodium. Alright, so that's our relationship, which means we also have a conversion factor, which is 1 mole over 6.02 times 10 to the 23rd, or 6.02 times 10 to the 23rd over 1 mole. And now it's just a matter of setting up our conversion and solving. So let's start with our known. Our known is 3.4 moles of sodium. Our unknown is atoms of sodium. And now we need our conversion factor. Now remember, our conversion factor has to get rid of our known, so we need moles on bottom, which means atoms on top, which gives us this factor, right? That means we're going to be multiplying by 6.02 times 10 to the 23rd. Now you're going to probably want to know, or maybe you already know from doing scientific notation, how to plug this into your calculator. But you'll just simply take that 3.4, so then times, and then I want you to use parentheses. So you'll do parentheses, and then 6.02, and then you're going to find a button on your calculator that's going to look something like this. So on your calculator, again, it'd be like saying times, you'll have parentheses, 6.02, and then you're going to look for a button that either is an E button or it might be EXP. So find a button on your calculator. It's going to either be EE or EXP, and you're going to hit that. So you're going to hit the EE or the EXP button, and then you're going to put 23 and then parentheses close. So again, EE or EXP, and then you're going to hit 23 and then parentheses closed, and then hit enter. And by doing that, that 6.02, hitting that EE or EXP in parentheses closed, that's going to be like saying 6.02 times 10 to the 23rd. Now, when you get your answer is going to probably look something like this. So it's going to say 2.04, and then it might go out to some numbers like 6, 8, and then you might see like an E, and then a 24, or it might even already have it times 10 to the 24th power. All that really means is it's like saying 2.0468 times 10 to the 24th atoms. Now you do want to round this to the correct amount of sig figs. Notice there's 2 sig figs in your known, so we're going to round this to 2.0 times 10 to the 24th atoms. And that's it. We're done. And that's it. So we know that in 3.4 moles of sodium, there's 2.0 times 10 to the 24th atoms. All right, one other way we might see a problem like this, it might say something like, again, another story problem, how many atoms are in 4.5 grams of sodium? Now notice with this one, now we're no longer in moles. Now we are in grams, which means we're going to have to do a little bit more in terms of our calculation. We still have our unknown, which is atoms. So let's talk about relationships. Now we already discussed, just like in the previous one, that 6.02 times 10 to the 23rd atoms of sodium equal 1 mole. But now we also have another relationship because we're dealing with grams. We know that in 1 mole of sodium, there are 22.99 grams of sodium. So we've got our two relationships. We can even write them out as conversion factors. So 6.02 times 10 to the 23rd over 1 mole, or 1 mole over 6.02 times 10 to the 23rd. And then we've also got our mass, so 1 mole over our molar mass, which is 22.99 grams, or 22.99 grams over 1 mole. Alright, now let's start with our known. Our known is 4.5 grams of sodium. Our unknown is atoms. Alright, and what goes in the middle? Alright, so let's start with here. We've got 1 mole over 22.99 grams, right? Notice that that will get rid of our grams and give ourselves moles. Second conversion has got to get rid of moles and give ourselves atoms. Notice we divided by mass to get to moles. Notice we multiplied by Avogadro's number to get to atoms, right? So get rid of moles, it'll give us atoms, and now it's just a matter of plugging it into our calculator using the same idea as what we just discussed before. So 4.5, we're going to do divided by 22.99, and then times, we're going to do parentheses, 6.02. Again, we're going to find that EE or EXP button, so times 10. We're going to hit 23, parentheses closed, and we should get a number that looks something like this. It probably is like 1.1783384. Sorry, let's write that again because things got a little blurry. So 1.1783384. And we could keep going. There's plenty more digits, and it might even go out to more for you. And then you might see like an E and then 23, or it might be like times 10 to the 23. And remember, that's all that really means, right? So let's round this based on sig figs. 2 sig figs would make this 1.2, and then times 10 to the 23rd atoms. And that's it. We simply have figured out that in 4.5 grams of sodium, there is 1.2 times 10 to the 23 atoms. A whole lot of atoms. Not quite a mole, right? Because 4.5 grams is not a mole. 22.99 grams is a mole. So that's why that number is less than 6.02. And that's it. If you should have any questions, let me know. But otherwise, now Miss Golson is going to give you an assignment out of the Chem File book. You've used the Green Chem File book before to do some calculations or practice with sig figs. Now you're going to use it again to do some calculations relating atoms and moles and grams. So I'll turn it over to Miss Golson, and she will guide you in doing the assignment out of the Chem File book. Let me remind you that with the Chem File book, maybe you don't already know this, but the assignment or the questions, the answers are in the back of the book. If you will look into the back of the book based on whatever assignment you're on, the topic, you'll be able to find it, and then you'll be able to find the answers accordingly. And so as you are working on it, please don't hesitate to turn to the back of the book and search for and find the answers for the problems. My point with that is that I don't just want you to have the answers. I want you to do the work, show the work. That's what I would be looking for, or I will be looking for, is the work, because it tells me that you know what you're doing, not that you can just figure out what an answer is. With that in mind, like I said, if you have any questions, let me know. Otherwise, I'll turn it over to Miss Golson, and she can get you started on your Chem File assignment. That's it. I hope you have a great day.